Hi future doctors, welcome to the next class. We discussed in previous class electric field intensity on axial line, equatorial line and at any point. Okay, now how they are going to ask problems we will see. Two dipoles they placed, same dipoles like this. Now what is the resultant electric field intensity at a point O which is at a distance small r from its center, they will ask. Now, whenever they are asking, you have to observe this point is on axial line or equatorial line. So, this will be applicable, helpful in magnetism and matter also. In place of these dipoles, they will give two magnets. So, 1 plus 1 offer we will say this. If you know this, there you can do very easily. What is the resultant electric field intensity on an axial line or equatorial line means for this left dipole, this is right dipole. For this left dipole, this O is on axial line. For this right dipole also, O is on axial line. So both are at a distance smaller. Both are short dipoles we are thinking. Then on axial line, so what is the direction of electric field intensity? Means, so on axial line always electric field intensity will be in the direction of dipole moment. Therefore, dipole moment is here right side. Therefore, because of left dipole, electric field intensity will be 2 kb by r cube. This is in which direction? Right side. That one only we will say I cap because dipole moment is in right side direction. Next, right dipole. So that is also magnitude same 2 kp by r cube because this point is axial line. Now what is the direction means? This is towards left. Therefore, this direction will be left. This direction will be right. Left dipole direction is right side, right dipole direction is left side. Therefore, this is along minus I cap. So, these two are vectors, both are equal and opposite. Therefore, what is the resultant? Means 0, correct? So, both are equal and opposite. Next, same question they ask like this. This is one dipole, this is another dipole. So, like this you have to practice. So, this point O, so from center of the dipole, it is at a distance r. Now, what is the resultant electric field intensity? At the time, again this is left dipole, this is right dipole. Because of left dipole, here direction will be in the direction of dipole moment. That is nothing but EL. So, because of right dipole, this is also right side. Therefore, ER. EL and ER both are going to be same. Therefore, both are in same direction. Both are in same direction means what we have to do? You have to add EL plus ER. So, 2 kp by r cube plus 2 kp by r cube. What you will get? 4 kp by r cube. Understood? Now, I am giving another two dipoles like this. Now, you have to observe carefully. So, now this is left dipole. This is right dipole. Now, this is the point there. O is a point which is at a distance small r from center of dipole, which is at a distance small r from center of dipole. Now, what is the resultant electric field intensity at O? So, this is left dipole. Because of left dipole, what is the direction means? In the direction of dipole moment. Because this point is for this dipole on axial line. So, EL is equal to 2 kp by r cube. What is this direction? Right side. That is nothing but I cap. Now, observe this dipole. This dipole is in upwards. Dipole moment is in upward direction. Now, this point is which line? Equatorial line. On equatorial line, kp by r cube. Now, what is its direction? What is its direction means at O, its direction is opposite to dipole moment. That is nothing but downwards. Now, how to find a resultant at O? So, at this point O, one is right side, another one is downwards. Therefore, what is the angle between these two? 90 degrees. Therefore, resultant at O is going to be root of EL square plus ER square. Is it visible for you? Yes, visible. ER square plus EL square. So now Kp by R cube is going to be ER. Then in place of Kp by R cube, what we can write? 2 times of ER. So EL and ER values you can substitute. How you will get this one means, I am writing here root of, what is EL? 2 ER whole square plus ER whole square. Therefore, root of 4 ER square plus ER square. That is nothing but root 5 ER square root 5 ER. What is ER? That is nothing but root 5 Kp by R cube. Correct? Here it is not visible. Now I am writing here root 5 Kp by R cube. So like this you have to practice. Next, if two dipoles they have given like this, one is downwards, another one is also downwards. Let us assume two dipoles, parallel dipoles. Now it is at a distance from its center R, from its center R. At this point O, what is the resultant electric field intensity? So this is again left dipole, right dipole. Because of left dipole, this point is on equatorial line. Whenever equatorial line, resultant electric field intensity will be opposite to dipole moment. Therefore, EL is also upwards, ER is also upwards. Both are in same direction. Whenever both are in same direction, what we can write? E naught is equal to EL plus ER. What is EL and ER? Both are equatorial line. Therefore, Kp by R cube. Therefore, you will get here 2 Kp by R cube. Correct? Next up. So, one dipole moment is like this. One dipole moment is like this. Now, what is the resultant electric field intensity at O, which is at a distance smaller? Again, this O is equatorial line. Now, this is left dipole. So, this is right dipole. So, because of left dipole, dipole moment is upwards. Therefore, electric field intensity due to left dipole is opposite to dipole moment. Now, right dipole, how you will get? Dipole moment upwards means equatorial line downwards. Therefore, ER. These two are equal and opposite. Therefore, both are going to be cancelled. So, like this, they are going to ask. This will be coming in magnetism and matter also. So, this is the point O. This is dipole moment which is at a distance smaller. So, another dipole moment they are giving like this. This is point O at a distance smaller from center. Now, what is the resultant dipole moment at O? I am taking this is left dipole. This is right dipole. You can take 1, 2, you can take A, B, that is your wish. I am taking like that. EL. So, now left dipole, this point O is on which line? Axial line. Therefore, because of left dipole, 2 Kp by R cube. Now, what is its direction? Dipole moment is right side, axial line. So, electric field intensity on axial line is in the direction of dipole moment. Therefore, EL is right side. Correct? Now, see this ER. So, for this dipole moment, this point O is on equatorial line. So, this dipole moment, right side on equatorial line, because of left dipole, right dipole, opposite to P. Therefore, ER is going to be Kp by R cube. At the time, how you people are going to get the answer? So, right side EL, left side ER. Now, what is the resultant? So, both are not equal and opposite. Equal and opposite means 0. Now, this is higher. Angle is 180. Then you have to subtract EL minus ER. What is EL? 2 Kp by R cube minus Kp by R cube. That is nothing but Kp by R cube. So like this they are going to ask the problems. Next, at any point whenever they are asking, they will give angle. You have to see very carefully. This is dipole moment at a distance r at a point P at 30 degrees. What is the resultant electric field intensity, they will ask. At any point formula we wrote yesterday, means previous class. Kp by r cube root of 1 plus 3 cos square theta. That value you have to substitute. So always you have to remember this angle should be in between r and p. Sometimes logically they will give this angle. This angle whenever they give, you have to take this angle. That's all. So always angle between direction of r and dipole moment like this. Sometimes they will give this is p bar, they will give r value, this is 120 degrees. At that time you should not take here 120 degrees. Always angle will be direction. Arrow mark you have to take care. So this angle you should take in diagrams. You have to see properly. Otherwise you will do mistake. Okay. So try to practice problems on these models. So numerical values by substituting here p and r, you can practice. I am not giving those here which are logically helpful for you. I am giving for you. Thank you.